Hello everyone. This session we will discuss the next type of Navy-based classifier, that is multinomial Navy-based classifier. So when we should use multinomial data Navy-based classifier? So when my data set is a text data set, right? If my data set is unstructured data set represented using the sentences, then you can go for the multinomial data set. So multinomial Navy-based classifier is suitable for the classification with the discrete feature, right? So here, like other techniques also, we need to consider the word counts for the text classifier, right? So here we will discuss with example how your multinomial Navy-based classifier works. So here is the formula for the multinomial Navy-based classifier, like your previous type of Navy-based classifier. We calculate the probability of the attribute for the given class label. So here is the formula: n factorial upon product of all the xi factorial into product of all the probability, as we discussed in the previous classifier. So we'll see with one example. Here, assume my training data set is given, which is represented by the variable simple underscore train. So if you observe here, my training data set is made up of sentence. So here my training data set contains 3 sentences. First sentence is call you tonight. Then second sentence is call me at cab. And third sentence is please call me please. So I assume this is my data set of Gmail system, and these sentences are the Gmail messages. And we want to predict here, right, whether the given message is a spam message or ham message. Here we want to predict whether the given, with the help of this model, we want to predict whether the given new message will be spam or ham. So this data set, which is represented in the form of sentence, we can't use as it is to build the model. So we need to follow some steps here, right, before going to build the model. So first we need to convert these sentences into the vector matrix. Here, my data set we need to convert into the set of vectors. These vectors represent the frequency count of each and every word occurring into the data set, right? And the name of these words. So here is the example. My data set contains total 6 unique words. So cab, call, me, please, tonight, and you. And assume this is my class label, right? Ham. So first document represents the type of ham. Second document is of type spam. And third document is again the type of ham. So this is my training data set. So with the help of this training data set, we want to build the model of multinomial Navy-based classifier, and that we can use to predict the class of the new sentence. So if you observe in this vector matrix, right, here my each and every cell represent what the frequency count of that word. So for example, here my call word is occurring one time into the first document. Then here again call word is occurring one time into the second document and in the third document also. Here you can observe please word is occurring twice in the third document. Here, please twice it is occurring into the second document, and so on. So this is the training data set we are using to build the model. And once you have built the model using multinomial data Navy-based classifier, that you can use to predict the class of the new testing data set. So here is the example. My testing data set is, for example, please don't call me. My new sentence is please don't call me, and I want to predict the class label of this new sentence. So again, we can't pass this query in the sentence form as it is to the model. We need to convert this into the matrix, right? So here, if you observe, we have represented this sentence into the matrix form, right? So 0011100. Right, so we'll discuss here how we can convert this given unstructured data into the matrix form, right? And then we can build the model and predict the class of the new query. So here is one example, that example and with the solution. So in the data set, there are total 10 words, right? So instead of considering the total number of documents here, we need to consider the words, because one document is made up of multiple words, and here we need to calculate the frequency count of every word. And that's why in the solution, we consider the total number of words in the data set. So for my example, total number of words are 10. You can count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 words are there. So here out of this 10, 3 are call. Call is coming thrice. You once. Tonight also 1. Then for me, frequency count is 2. For cab, it is 1. For please, it is 2. Then here, we want to calculate the probability with respect to the class label ham and spam. And that's why we again consider here the word count for the spam and ham class label. So there are total 7 words. Those are representing the ham words. So here, for example, 2 documents are there with the ham label, first and third document. So if you observe how many words are there, 1, 2, 3, 4, 5, 6, 7, right? 6, 7. So total 7 words are there in the document. Those are represented by this label ham. And 3 words are there though in the spam document, right? So cab, call me, that is occurring 1 time. So right, so total 3 words are there in the spam. So call me and cab here occurring once in the spam document. Now we can see the solution here, how you can calculate the probability of my query point for the class label spam and ham. And we check for the maximum probability here. So probability of spam is equal to 1 by 3. Right? So 1 document is there out of 3 for this spam label type, right? So my probability is 0.33. Then my query says what? My query point includes here call word, me word, and please word, right? So for this, we need to calculate what? The probability of spam label and probability of the ham label, right? So for call, probability of the call for the spam is equal to 1 divided by 3. Actually, instead of 1 here in the numerator, we are considering 1 more 1, that is 1 plus 1 here, because to avoid the divide by 0 error. See, some of the documents can have here, some of the words can have the 0 count. So if we consider the 0 count for one of the word, it will completely, that term will become 0 and it will lose the information. And that's why to avoid this problem here, we use the 1 in the numerator everywhere, not in these only one probability term, but in all the terms, right? So 1 plus 1. So my call is occurring only 1 in the spam, and this 1 to avoid the problem of what? Losing the information. If this will become for some of the words, if it becomes 0, it will lose the information, because we use in the product of all the probabilities in the Navy based classifier, right? Then in the denominator, instead of the number of documents, again we need to use the words here, 3 plus 10. So there are 3 documents and plus 10 words, total 10. So why we are using here 10? Because this probability should not exceed the 1. My probability should be between 0 to 1, right? So that's why we are using in the denominator 3 plus 10 here. So my complete term becomes here 2 divided by 13, and we are getting here probability 0.15 for the call for the spam class label. Then similarly, we are calculating the probability of the me word for the spam class label. So again, we are getting here only one word is there of me in the spam document. So again, it will become 1 plus 1, 2 divided by 13. That's we are getting here 0.154. Then please to word is not occurring into the spam document, but my query point includes the please. So here is the example. So if we consider only 0 here, because please is not occurring in this spam document, so this count will become 0 and whole term will become 0, right? And what will happen when we will multiply this probability with other probability, this complete probability of the query for the given spam will become 0, and we will lose the information about call and me also. And to avoid this, we are adding 1 here. So this term will become 1 by 13 and my probability is 0.07 here. So now calculate the probability of my testing query with respect to spam class label. So it is 0.33 into 0.154 into 0.1.4 into 0.07. So we are getting here probability 0.00060. Similarly, you can calculate the probability of the given query for the ham class label. So individual ham class label, out of 3 documents, 2 are there with this ham class label. So my probability is 0.67. Then again calculate the probability of call for the ham class label. So 2 plus 1 divided by 7 plus 10, because 7 words are there into the ham documents, right? And 2 plus 1, because 2 times call is occurring into the ham, plus 1, try to lose avoid the problem of losing information. So we get here the term equation 3 by 17, that probability becomes here 0.17. Then calculate the probability of me for the ham. So using the similar formula, we get here the probability 0.117. Then calculate the probability of please for the ham, it will become 0.117. Then take the probability product of all these probability. So we get here 0.67 into 0.17, 0.17 into 0.17. So my probability comes here, that is 0.0025. So if you observe, my probability of this spam, right, probability of the query for the given class label spam is less than probability of the query for the given ham document, right? So for ham document, my probability is maximum, and that's why my query is predicted as ham here. I hope, student, you are clear with the solution. The formula that we are using is similar to the Navy-based classifier, general Navy-based classifier, only instead of the number of documents, here we are considering the number of words, right? Frequency count of the words. So what are the steps to convert here the data set into the vectors, right? So we need to use some scikit-learn library, right? So with scikit-learn syntax, we will discuss here how you can convert your text data into the vectors, and that way you can pass to the model, right? To build the model and to test the predict the class of the new query point, right? So here is my array. Here we are creating the array of training data set. Simple train is my variable name, equal to this array of string sentence, right? So there are 3 sentences in my array. Call you tonight, call me a cab, please call me please, right? Then using this function of count vectorizer, right, you can convert your data set into the vectors, right? So here is the library from sklearn.featureextraction.text import count vectorizer. Then create the object of this count vectorizer. So vect is the name of my object. Then use feed function to execute this count vectorizer function, right? So here we are passing a simple train, my training data set, right, as a parameter, because for this training data set we want to use the function, right? Then this feed function will convert your sentence into the vocabulary. Learn the vocabulary of training data set, means it will convert the sentence into the vectors, right? So if you want to extract the name of these vectors, right, this function not only creates the vector, but also it performs the tokenization. It divides your sentence into the individual tokens, right? So if you want to extract the name of these tokens, right, you can use here the function get underscore feature underscore names. So this function we have used here, vect dot get underscore feature underscore names to extract or display the name of these features. Those are tokenized using this count vectorizer function. So here is the output. So in my 3 sentences in my training data set, these are the unique words: cab, call, me, please, tonight, and you. Right? Now we can use here the vect dot transform function to convert this training data set into the document term matrix. Right? The transform function we can use to convert this training data set into the document term matrix. So here is the function. Simple train DTM is the variable we are using to store this document term matrix, right? Vector transform and simple train data we are passing to convert this document into the document term matrix, right? So if you display here this variable, simple train DTM variable, you can find this is the data right here in the matrix, right? Document term matrix. So here in the document term matrix, my rows represent the documents and column represent the terms. Then with the help of toArray function, you can display this matrix into the dense matrix format. So simple train DTM dot toArray will display this result where you can observe my each and every document is represented in the form of documents and its equivalent and its term frequency. So if you observe in the first document, my this one represent what, which word, that is call word, right, which is occurring one time. Then last two words, tonight and you, right, is occurring one time. Here in the third document, please word is occurring 2 times, right? So you can see here as output of this simple underscore train underscore DTM dot toArray, right? So once you have converted your data into the term document matrix, right, you can build the model. And that model you can use to predict the class of the new query. Again, new query you need to convert into the document term matrix, right? Or the vector, because your a query will have only a single document, so you can convert into the vector. So here is the syntax to convert your vocabulary or examine your vocabulary and document term matrix together. So your vocabulary is having what? Your class labels, or sorry, the word labels, right? And the document term matrix is having what? The frequency count of the word, right? So if you want to see this vocabulary and this matrix together, you can use this function pd.dataFrame. So first parameter that we are passing to this function is my toArray, where we are storing these term document matrix. And second parameter we are passing here the column names. So columns equal to vec.getFeatures names. So you can observe the output of this data frame in terms of vocabulary and their frequency count as a term document matrix, right? I hope students you are clear with this. Then see the scikit-learn code to build the model here, right? And to execute and transform this your query into the vector. So here simple test is the variable we are using to create the to store the query sentence. So my query is here, please don't call me. Then you can convert this into the document term matrix using the transform function. So here is the method vec.transform simple test. Like your training data, we have used here the transform function to convert this simple text into the document matrix. Then here we are converting this into the array, right? So if you display this into the form of array, you will find here in my query point, 3 words are there: call, me, cab, right? Now we can convert this again into the vocabulary and document term matrix together, right? So using data frame. So data frame first parameter is my document term matrix of this testing data set, and the columns of these features, names of these features, like your training data set. So my query will be like this, right? So call, me, please. These are the 3 words in my testing data set. Now, if we summarize here, what functions we use here to convert your training and testing data set into the vocabulary and the term document matrix. So vec.fit function with the training data set to learn the vocabulary of the training data set, right? Then vec.transform for the training data set uses the fitted vocabulary to build the document or matrix from the training data set. And vec.transform test, we use the fitted vocabulary to build a document or matrix for the testing data set, right? So here we use these three functions. Now we'll discuss the scikit-learn code for the multinomial navy-based classifier to build the model, right? So how we can build this model here? So from sklearn.navy base, right? Navy underscore base, import multinomial NB. So my inbuilt class is here, multinomial NB. Then create the object of this multinomial navy-based classifier, then train the model using the fit function. The nb.fit, we are passing here the x train and y train, right? Then here for mod time, we are using with this fit function to find out the how much time is required to build this model, right? So this is optional, right? So next we are using the predict function. Once you have created the model, you can use the predict function to predict the class of the test data set. So here we are passing the test data set as a parameter to the predict function, and y predict class will have the predicted class for this. Now, if you calculate the accuracy of the model, right, using accuracy underscore score. So here we are passing y test and predicted y as a parameter, right? So you will find here the 98.85% is the accuracy given by this model with the help of this accuracy underscore score function, right? So I hope student you are clear with this multinomial navy based classifier with this scikit-learn code. Thank you.